Now we shall continue with process termination. This is the operation where running process finishes its task and using the exit system call. Okay, it informs the operating system that it's done. So when a process terminates, it can return a status value, typically an integer, to its parent process. So this status value can indicate the success or failure of the process termination. There are several ways to terminate a process. A process finishes executing its code and asks for the operating system to stop it using the exit system call. This is a planned and controlled termination. So the process might return a status code, typically an integer, to its parent process via the wait system call. Okay. The status code provides information about the process execution, and all the resources used by the process, like memory, open files, the input-output buffers, are released. In termination by parent process, the parent process, the one that created the child process, can also decide to end the execution of its child process for various reasons. For example, the child has used too many resources like memory and the parent decides it's time to stop it, or the task assigned to the child is no longer needed. Or maybe the parent process itself is ending, so that operating system doesn't allow child process to continue if the parent process terminates. In the forced termination, sometimes a process can be forcefully terminated by another process, typically by its parent process. However, this is usually done with great care because killing processes randomly could lead to problems, okay? So the parent process must know the identity of its child process to terminate them. To illustrate this, think of a program running in a Linux system. When the program is done, it can use the exit system call to terminate and provide an exit status like exit 1. Okay, this status code can be checked by its parent process. Okay, so it's like exit 1 or exit 255. And this status code can be checked by its parent process if it exists. Okay, the parent process might use the wait, okay, system call to get information about the child process's exit status and process identifier. This way, it can determine which child process has terminated. And also, there are also two funny naming that I want to mention: orphan and zombie processes. They are the terms used to describe the special states of processes in a computer system. A zombie process is that it has terminated but still exists in the process table. When a process finishes its execution, it sends its exit status to its parent process, but its entry in the process table is not immediately removed, okay? So this terminated process in the process table, waiting for its parent to collect its exit status, is called zombie process, okay? So zombie processes exist briefly, waiting for the parent process to perform the necessary cleanup using the wait system call. And once the parent collects the exit status, the zombie process is removed from the process table, okay? On the other hand, an orphan process is a child process whose parent process has terminated or been killed, okay? So orphan processes can be problematic because they are not immediately adopted by the parent process in most systems. So in Linux system, orphan processes are eventually adopted by the init process. The init process periodically calls wait, okay? Init process periodically calls wait to collect the exit status of any orphan process. By adopting orphan processes, the init process ensures that these processes are removed properly and preventing them from becoming permanent zombies. So in simpler terms, a zombie process is like a ghost of a program. that has finished its job, but it's waiting for its parent to acknowledge its condition. Okay, and another orphan process is like a child left without a parent. It's taken care of by a special garden. In Linux, we call this garden in its process to make sure it doesn't live as a zombie forever.